Good morning guys. We're back at it again with another video. So the framers, they have finished the roof, which is why I'm standing in shade right now. And they just have a little bit to do on the mechanical room and then a couple walls in the on the second story that they have to frame up. But other than that, they are pretty well done and we are ready to move on to the rough-in stage. So you'll see a video on the framing later this week. Now, since the roof and the overhangs are finished, this is a really good time to show you about some of the passive solar design details that we incorporated into this house. Now, one reason why this is really important to talk about is because for the vast majority of homes that I see that are designed, or how the homes are oriented on their lot or land, is that they do not take into account the orientation of the building or the path of the sun in order to make their home more energy efficient. Now, this topic is generally not brought up in general construction because you got to think, if a planner or a builder is designing out a subdivision or something like that, their goal is to fit as many homes in that space as they possibly can. So they are not necessarily thinking about the orientation of the house or the window placement or the overhangs or anything like that when it comes to designing the lots and the actual homes that are going on that. Now, why this is really important, especially coming from a solar and electrical background, is that the biggest load in most homes when we're calculating solar loads and electrical loads is going to be the HVAC. So it's going to be the heating and cooling system is going to be garnering the most amount of energy in your home. So if you think of it from an electrical standpoint, say you just have like a standard air conditioner, the less that your air conditioner has to run, obviously you're going to be saving more money, especially if you're connected to the grid. So it's just going to save you a lot of money over the course of many years if you take some of these ideas and implement them into a house design. And it's the same thing if you're going to be heating and cooling your home in a colder climate. Say you're going to be using natural gas as a way to heat your home through a furnace. This is something that would also be applicable to that, because the less that you need to heat your home and the more that the sun can heat your home, the less energy and the less resources that you're going to need to create a very comfortable climate. And that's really one of the most important things with a home design, is that you want to make this comfortable. And obviously temperature is one of those very important factors. Now, passive solar design is not an overly complicated topic. You definitely hear more about passive solar design when people are designing and building typically an earthen style structure. So if they want to do an earth ship, they want to do earth bag or something like that, or straw bale, then the idea of passive solar design and making that structure much more energy efficient is definitely talked about more. But for general construction, it's typically really not brought up. And I see a lot of homes in our area, and they're manufactured homes. And the orientation of the home is such that the long walls are going north and south as opposed to going east and west. Now, just with taking the orientation of your building and taking it and putting it 90 degrees from where it is can actually make a significant difference in the heating and cooling loads in that home, believe it or not. So I learned about a lot of this stuff from Brad Lancaster's book, Rain and Water Harvesting for Dry Lands and Beyond, because he talks a lot about stacking systems and basically making an energy efficient home in there. Now, I've got some great video clips that I made with a SketchUp animation showing basically our home and how it's going to passively heat and cool itself throughout the year. But right now we're about 3 weeks away from our summer equinox. And so I can basically show you right now how this house is actually shading itself on the south side without just with the design of the house. So to give you guys a gist of the orientation of our home, coming out this way, out our patio door is east. That would make this south. That's going to be north, and then that is going to be west that way. So the long part of our building is going east and west that way. So this is our south facing wall. And right now we've got a massive 5-foot overhang, and you can basically come down here and see that we're not going to get any solar gain coming in through these south-facing windows, but on our south-facing wall during the hottest part of the year, you can see that our overhang is basically casting a shadow over the south side of the building. So we're almost at about noontime, and that's when the sun is obviously going to be highest in the sky there. So we're basically going to keep all these windows shaded throughout the summertime, and we're not going to get any gain coming through those windows. Since we're not going to be getting any direct sunlight through any of these south-facing windows here, it's going to keep the space inside much more cool and comfortable, especially during the summertime. Now, when we go out our south-facing wall here, when it's more winter time, that sun is going to be much lower in the sky. So as the sun is lower in the sky, we're going to actually get quite a bit of thermal gain through those windows, and the concrete slab here is going to act as a heat sink, and that'll help keep the house much warmer during the winter time. And then if you remember from when we poured this slab, there's also 2.5 inches of insulation under this 4-inch concrete slab. So that keeps this concrete slab isolated from the ground below. So as we get that summer sunlight hitting this, it's going to heat up the concrete slab, and then basically as the sun goes down, that heat will be released back into the house. So just a couple of simple ideas like that can make a significant difference in terms of how comfortable your home is and how much energy it takes to heat and to cool it. All right guys, since I can't fast forward to our winter equinox, let's go through our SketchUp model and some videos that I made showing basically the sun cycle and how it's going to change on our house. So Jake, who designed our house, also did a SketchUp model for us, and he geolocated the house along with the shadows so that we can do some sun modeling with it. So right now we are at the summer equinox, which is June 21st in our hemisphere, and we're going up to noontime. So you can see that there is no sunlight going in through those south-facing windows. And as we go to the evening, we can see that it follows the same pattern there. Now, the difference comes when we go to the winter equinox. So right now, we are at the morning of the winter equinox, and you can see just how much more sun that south-facing wall is getting because the sun is going to be much lower in the sky. So now we're going to the winter equinox evening, and we're going to get a couple different angles here just so that you guys can see things a little bit more clearly. So now we're going back to our summer equinox at a different angle here, and right in the morning time, you're going to see that the sun rises actually north of east and then goes up, goes a little bit past east and west, and then sets north of west. And again, we're not getting any of that solar gain going through those south-facing windows. And we're going to switch back to the winter equinox and just kind of see the difference here. And we've got a couple more different angles. But this is really cool just to be able to see it. You don't need to have this modeled in 3D to be able to do this. I'll give you some resources if you want to figure this out without using SketchUp. But now we're going to our winter equinox evening, and we're going to be getting a lot of that solar gain during the winter time. I'm actually kind of worried during the winter time we actually might get too much solar gain through some of the windows. But now we can kind of see the difference here. So we're going from the winter equinox to the summer equinox without changing the time of day. So you can see how the shadow on the house will change throughout the year. Now we're going from our summer equinox and we're going to our winter equinox. So we'll be able to see as the time of year changes, the amount of solar gain that we get through those south windows will increase as well. And that's some of the basics of passive solar design with a home. Now this drone shot is showing the west side of our home, and you can see that there's only one little window in the upstairs bathroom, which just will give us some natural light in that upstairs bathroom. But we don't have any big windows on that west side because in the afternoon, when it is hottest here, you don't really want to be getting any solar gain through the west side of the house because it's just going to be hot, and any rooms where that sun is going to be getting into, there's going to probably be about 4 or 5 hours of solar gain through those windows, and it's going to make those rooms much warmer and most likely much more uncomfortable as well. Now, the other beautiful part of the orientation of our house is that on the east side there, it is always going to be in shade, partly because of the patio above it, but also because the sun is going to be setting on the opposite side of the house. The patio is always going to be in shade. So when we're out there in the evening time with friends and enjoying ourselves, everyone's going to be comfortable because you're going to be in the shade, and shade is one of the most important things in Arizona specifically to make a very comfortable outdoor space. Now, the book that I've mentioned a number of times on my channel here is Rainwater Harvesting for Drylands and Beyond, and Brad has a dedicated chapter on integrated house design, which takes into account all these things that I've been talking about in this video, as well as where you should be placing shade trees and whether or not they should be deciduous or non-deciduous. There's just so many different little things that you can really start to map out and plan out in advance to make a very energy efficient and comfortable home. If you already live in a home and you're experiencing maybe some of these issues that I've been talking about, like just getting too much solar gains through certain parts of the home, definitely read through that book, because there's lots of things that you can do after the fact. If the house has already been built and you've already got your overhangs and your windows, there are still things that you can do to make it more energy efficient. The more energy efficient that you can make your home, the more comfortable it's going to be. It's going to cost less to run. And especially when I've heard of different energy bills, especially here in Arizona during the summertime, some people are spending between $300 to $400 a month to cool their home during the summertime. And if you can drop that down to maybe $100 or $150 a month, that could save you over $1,000 or $500 to $1,000 in just a year. And just think about how much more money that you're going to be saving over the lifetime of that home. It can be quite significant, and that's why it's so important to really take this into account if you're going to be building a home from scratch, and understanding this before you do so that either yourself or the architect that is helping you design it, some of these strategies can be implemented on your home. All right, guys, I hope that helps you understand passive solar heating and cooling. Like I said, this can be applicable in the desert here in Arizona, or if you're in Canada or something like that, where you have a much cooler climate. Some of these strategies can be implemented as well. It just takes a little bit of time, a little bit of thinking, but again, it's not overly complicated or anything like that. And Brad even has lots of formulas and lots of ideas in order to calculate, how big your overhangs need to be based on the roof height and how tall the windows are, et cetera, where you can place shade trees and all that kind of jazz. Really having an integrated design is going to make the home just so much more efficient. And I'll be talking more about this as we progress further with this home build. Awesome, guys. Thanks so much for watching. We'll catch you on the next video in a couple days with the boys finishing the framing. And then, like I said, we're going to be moving on to the rough-in stage. Awesome, guys. Thanks so much for watching. We'll catch you on the next video. Talk to you soon. Peace.